Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on word ladder. It's a commonly used problem when you go for FANG level interviews or very tough coding interviews. So yes, it's from really hard category as well. But yeah, the solution would be really simple to understand, and let's just quickly jump into the problem statement, understand it and start solving. Okay, so last time we have solved find median from data stream. We'll mark it check. You can find it in the list. Let's start with word ladder. And again, as I mentioned, I have seen this question being asked in interviews that are of the top product based companies, especially for the FANG interviews. So let's jump into the problem. A transformational sequence from word begin word to word end word using a dictionary word list is a sequence of word begin word words and then such that every adjacent pair of words differs by a single letter. Okay, every s of I for one in range ik is in the word list. Note that begin word does not need to be in the word list. Okay, sk is equal to the end word. Given two words, begin word and end word, and a dictionary word list, return the number of words in the shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. Okay. So the question is like this, that we are given a begin word hit and an end word cog. With each iteration we can change only one character. Okay, and we are given a word list as well. So we have to see if we can use these words from the word list and transform from hit to cog, right? From hit we can change one character. Let's see, as they have shown, from hit we change the I and become hot. So from hit we go to hot. Then from hot we change D and go to dot. From dot we change the T and go to dog. From dog we change D and jump to cog, which is our end word. Okay, so this is the overall example. This is how we have to move. Of course, we have to find the shortest path. There could have been other solutions which might consume a bit longer path, but we have to figure out the shortest path. Now the thing is, I hope that at least the question is clear, that we can only change one letter at a time until we reach the end of the word. If we cannot, then we return 0, right? The thing is, how we can solve it is, or before I suggest, please take a minute and just think of an approach that you would take to solve this problem. Ready? Okay, so one of the possible solutions could be that one by one you check all the possible paths, and then you return the path that has minimum number of words required, right? That can be very time consuming as well, or yeah, that can be actually very time consuming, plus it would be not so complicated but slightly complicated as well. But otherwise what we can do is we can go through one by one. We'll do a breadth first search. Okay, so what we are going to do is, we can do a BFS on this until we reach from the begin word to the end word. And in order to improve the time complexity, we can do the BFS from both the ends. So reaching from hit to cog is same as reaching from cog and transforming it to hit, right? So we'll do the BFS from both the ends so that we can meet in the middle, and then we can have a solution. Now in order to make it the shortest transformation, so that we do not have to check for all the sequences, in order to make it the shortest transformation, we'll swap between the BFS from the front end or the BFS from the second end or the last end, based upon whichever length is smaller. Let's say from hit we have transformed from hit to hot, on the other side we have transformed from cog to dog and then dot. So on the other end we have three words already taken. From the begin side we have taken only hit and hot. So we'll do the BFS on the smaller end, that is hit and hot, and from hot we'll try to shift to dog, and we see or dot, and we see dot is already part of the other set. So we'll be sure that we have found our shortest path. Okay, We might need a few variables, and yes, sets would be really helpful in this case, because that will give us faster time complexity for the search process, right? Like we have this word list, we'll simply convert this to a set as well. Okay, so with this, let's start with the solution, and please pay attention. This is actually a hard level coding question, I would say, and yeah, please pay attention. Okay, let's start. So first we'll convert our word list to a set, such that it is easier to look up. So convert word list to set for easier and faster lookup, right? So we'll create a set of string, we call it word set, is equal to new hash set, and in this we'll pass our word list. Okay, okay. Apart from this, the begin word may not be part of the word list, right? But the end word has to be part of the word list. But what if the end word is not in this list? That means the solution does not exist at all, right? So we can make that as our base condition. So we'll say first base condition would be, or we always type base case, so we'll say base case. It feels more towards condition. Base condition would be that check if end word is in the word list. Okay, so we'll check if does not exist word set dot contains end word, right? So if word set, so we have created word set out of our word list. If word set does not contain this end word, solution does not, transformation is not possible, so we can simply return 0. Transformation is not possible, right? Okay, now since we want to perform bidirectional BFS, so we want to create sets from the front end and the end side as well, right? Plus we'll keep another set for the characters to know that we have visited certain words and certain words are not visited, so just to keep count of it. So we can say use bidirectional BFS to find the shortest transformation journey or a sequence. Okay, so we'll create set string. First we'll give begin set is equal to new hash set. Okay, as of now it is blank. Similarly, we'll have set string end set is equal to new hash set. As of now it is empty as well. Then we have set for visited is equal to new hash set. Again, for the beginning it is empty as well. Now we'll add the begin word to our begin set and the end word to our end set, so that they are the two ends of it. So we can say begin set dot add begin word and end set dot add end word. Okay, now one more thing is, we do not have to return the complete sequence, right? We only have to return the number, that is how many words it will take or how many steps it will take. So we'll create or how many levels it will take. So 1 2 3 4 5, right? So we'll create levels for it. We can say variable to track total steps words or levels. So we can say int level is equal to 1. Why 1? Because when we are beginning with the begin word, we at least know that we have our first word found, right? So we have our begin word. Okay, apart from this, let's check what else do we need. We got our begin word, we have our begin set, we have the end set. We'll start with the transformation. So we'll say while while begin set is not empty and end set is not empty. So when this happens, we'll break a loop. Okay. So since we want to find out the shortest path, we are only going to perform our overall journey on the smaller set. So we'll check which set is smaller. Whichever one set is smaller, we'll swap it with the begin set. So we'll just choose the smaller set. So we can say if begin set dot size is greater than end set dot size, we'll create a swapping set. String temp is equal to, we've assigned temp the value from begin set, and then begin set will get the value of end set. It's just normal swapping that I'm doing, and end set is equal to temp. Okay, so if begin set is smaller, we start directly with the begin set. If end set is smaller, we start with the end set, and in order to start with the end set, we are just swapping the end set with the begin set, right? And actually with each iteration, begin set and end set will become smaller. Like for the first case, both of them have the 1 words in each, begin set and the end set, as of this case. So right now the begin set has the word which is hit, and end set has the word which is cog, right? Cog. Now both of them are same, but once we add another word to begin set, let's say hot, then end set becomes smaller. Then we'll start with the end set. From cog will shift to dog, right? And then begin set will be smaller, or both of them will be equal, so we'll not swap. Okay, so this is just to maintain that we reach the solution in the shortest path. Okay, let's start. So we'll have another set for our next level as a variable. So we can say new hash set. Okay, now what else do we need? So we'll start with our traversal for string current word. That will come from begin set, since there is only one word as of now. So we can say at this point in time, the word that we have is what is the word that we have? We have hit, right? Okay, then we'll move it to characters. So word chars will be current word dot to char array. Okay, now because we can change only one character at a time, we move from the complete word to character. Okay, now we'll start the traversal on the words. So we can say int I is equal to 0, I is less than word cast dot length I plus plus. Okay, now what do we need to do? First let's pull out the as part of the algorithm, we'll pull out the current word, which will be the first element, that will be h. Okay, so we can say char current, we have already used original character is word chars of I. Okay, so in this case, for the first iteration, we got here, we got hit, it was transformed to character array, we got h, right? So we get h here. Okay, we got h. Now we want to do a sequence change. Like, how do I know from hit I can move to hot, dot, dog, lot, lag, anything? Maybe from hit I could have moved to kit, right? So I have to check for all the sequences possible for each character. So from h we will check whether we have AIT, BIT, CIT, DIT, AIT, FIT, GIT, and like that till Z. Okay, so we'll check for char C equal to A, C less than equal to character Z, C plus plus. Okay, now if the first character is same as the original character, right? If the first character that we are getting, let's say it was AIT, or whenever our C arrived to H for HIT, then we do not have to perform, because that is the original character, right? H is the original character, so we do not want to perform any operation for H. We want to check for other possibilities of AIT, BIT, CIT, and like that. So we'll create a case to continue from that part. So we can say if words chars of I is equal to C. Okay, right now that is, so that when we are at H, we'll ignore HIT. When we are at I, we'll ignore I part of it. So we'll take HAT, HBT, HCT, HDT, but we'll ignore for HIT. Similarly, when we'll arrive at T, we'll take HIA, HIB, HIC, HID, but we'll skip for HIT. So whatever is the value for that I, if word chars of I is equal to C, for this case we do not want to perform anything. We'll say continue to skip. Okay, now if this doesn't happen, we can say we'll replace the original character with the new character C. Okay, so we can say word chars of I is equal to C. So let's say if C's initial value is A, since we are starting it from A, our original character is H, we have stored it in a separate variable. I'll comment store original char. Okay, so we'll assign word chars of I, so the first position H will get removed and changed to C. So we had HIT, it will now become AIT. Okay, now we would like to search if AIT is in this list or not, sorry, in this provided list or not, right? So first let's create the transformed string. So string transformed word will now be new string, and will pass word chars. So at this point, for the first case, we have AIT here. Okay, now we want to check if, before checking in this stage, okay, since we have two sets performing the BFS, the begin set and the end set, it can happen that we reach from HIT to let's say DOT or DOG after traversals, many traversals, and we'll simply check if dog is part of the end set. That means end set has reached from cog to dog already, and from dot we are reaching to dog. That means we have found the overall solution and we can return the answer. So we'll simply check it in the end set. If end set dot contains transformed word, if this happens, we'll return. What do we want to return? So we have a level to keep track of total number of steps, words, or level. So we can simply return levels, whatever number of levels we would have reached by then, level plus 1 for that current word. Okay, return returning solution. Okay, otherwise we'll check if this transformed word is available in our word list or word set, right? So we'll check if word set dot contains transformed word, right? Now apart from that, what else should we check? What if word set does contain HIT, but HIT was already visited? That means from the end set side BFS, we have already visited not HIT, but whatever word that we are picking up. In this case, that is AIT. So let's say AIT was already picked up from the other instance. So we cannot check that. We cannot take that one in our current sequence of solution. So for this one we had created our visited set, so we'll check that this must not have been visited. So we'll check not visited dot contains transformed word. Okay, I may need to expand this a little. Okay, so we are here. Okay, now if word set does contain this and this has not been visited, we need to add it to our so we can actually move from HIT. Let's say AIT was not contained here, right? So we search for BIT, CIT, DIT and A to Z. We check that nothing is available. Then we I went plus plus, and from H, now our current original word would be I. Okay, I'm just giving you the example for the next iteration. And from HIT we transform to HOT. Okay, and hot is available in the list, right? So the transformed character was HOT, and HOT is available in our word set and it was not visited. So we would like this word to be our next beginning word, right? So we'll add it to the temporary set that we have created, that is next level. So we can say next level dot add transformed word. And if you see for the while loop, this next level will always get refreshed, right? It will only be for this for loop to be running. After that, for each level we'll be refreshing it. So next level will always become blank. Okay, now next level will get the word HOT. But let's jump to the previous example that we were running. Okay, AIT was not possible, we reached the HIT, and from I we switched to O, and hot was available. So we added it to the next level. What else we need to do? Now we need to mark it visited, right? So visited dot add transformed word. Okay, now let's check again. So we had started with HIT. Okay, we first character from the word HIT was H. We kept on moving for H. Checking AIT, BIT, CIT, DIT and all the possible combinations. Now since there was no solution found for AIT, BIT till ZIT, I++, we moved to I. From HIT, the next character was I. Then we searched for HAT, HBT, HCT, and finally we reached HOT. Okay, now we checked that HOT was is part of our word set, so we marked it as for our next level, that will start from HOT. Now we added to the HOT and we marked it visited. Okay, now when all of this is done, that means we have done the overall transformation with for each of the word that we chose. But if we found no solution in this loop, let's switch back the character to our original character. So we can say word chars of I is equal to original char, right? Okay, now when we come out of our secondary loop, so first loop is over, we did not find HIT, HBT, AIT, CIT, BIT, DIT, anything till ZIT. We didn't find anything here, so we swap it with the original word, so it became HIT again. Now I plus plus, and we started the same process with HAT, HBT, HCT, HDT. Okay, now once the complete loop is over, okay, we'll move to the next part, right? Now the for loop was already over, the overall for loop that was running. So once the overall for loop is done, okay, where we were contradicting the same thing for each word in the begin set, because right now we have only one word in the begin set, but one by one we'll get, after achieving from HIT to HOT, we'll get the HOT added as part of the word set as well. So or not added, but we'll add it. So let's add it to the begin set. So we can say begin set is equal to next level, right? Because in next level we are already storing the sets, so now begin set will get the values from the next level. And yeah, with this we can also say level plus plus. Okay, now what will happen is, let's go to the solution part now, that we found from HIT, that was already part of our begin set, right? And end set had cog. We found the word HOT. HOT was then added to next level. From next level, we then transform HOT to our begin set again. Okay, so now begin set gets the value of HOT. Next time we start from the end set. Since end set will become smaller, so we'll swap end set with the begin set. Now begin set will have the values of end set, that will be COG. Now we'll do the transformation from COG, and from COG we'll get it transformed to DOG. Now once we have transformed it to DOG, and with each level we are increasing the level as well. To calculate total steps, words or levels in the transformation. Okay, so from COG we'll go to DOG, and then again we'll switch back, since original begin set is not smaller, begin set is not smaller than is not bigger than the end set. We'll still be continuing to search in the end set part, that is the begin set only, right? So after COG we reach till DOG, and now in the begin set, that is this became the begin set, we'll search for the next word, we'll reach DOT. That time we'll do the swap, and from hot we'll search for the next word, and we will find dot. When we find dot, we'll come to this part of the code where we search that dot is already contained in the end set, right? Since dot is already contained in the next set, because in as of this moment, as of the solution part, begin set will have hit, hot and dot. End set will have begin set will have hit, hot, and it will be processing dot. End set will already have cog, dog and dot. Since dot is already available in the end set, that means we have reached our final solution. So we'll increase one level for that word and we'll return it, right? But if after all of this, if after doing all of this we do not find any solution, we'll return 0. No solution found. Okay, let's run it. I know the solution was very tricky and complicated, but yes, this is quite complicated solution. Oh sorry, this is quite complicated problem. What did I miss? Okay, we missed ampersands. Okay, let's run. Okay, let's submit. And since we are doing the BFS from two ends, we do have a better time complexity. With single BFS we would not have achieved this good time complexity, but it would have still been better. Okay, yeah, so that is all from today's video, everyone. For anything, please let me know in the comment section, and I'll be happy to answer. Plus yes, the overall time complexity will come out to be m into k into n, where m is the length of each word, plus k will be the size of current set. So at each moment here we are processing a next set. So k will be the size for each current set, and final n is going to be the total number of words in the word list. Okay, with this that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.